Good evening, sir. By the way, I'm Jeremy Caliat. I'm here to report about the different ocean current. So, first is the mass of flow of water or currents are essential to understanding how heat energy moves between Earth's water bodies, land masses, and atmosphere. The ocean covers 71% of the planet and holds 97% of its water, making the ocean a key factor in the storage and transfer of heat energy across the globe. The movement of this heat through local and global ocean currents affects the regulation of local weather condition and temperature extreme, stabilization of global climate patterns, cycling of gases, and delivery of nutrients and larvae to marine ecosystem. Ocean currents are located at the ocean surface and in deep water below 300 meters or 984 feet. They can move water horizontally and vertically, which occurs on local and global scales. The ocean has an interconnected current or circulation system powered by wind, tides, Earth's rotation, or Coriolis effect, the sun solar energy, and water density differences. The topography and shape of ocean basins and nearby landmasses also influence ocean currents. These forces and physical characteristics affect the size, shape, speed, and direction of ocean currents. Types of ocean currents. Horizontal currents. This includes surface and deep water currents. The first is surface currents. They are currents that occur on the top layer of the ocean and are primarily driven by wind. They affect the water in the upper 300 meters of the ocean. The currents mirror the large-scale circulation of air mostly derived from unequal heating of the planet's surface by the sun. The currents therefore form rotating system in the middle of the ocean system, called gyres. Surface currents are responsible for redistributing heat and planetary scale. And the second is the deep water currents. As opposed to surface currents that occur on the upper surface of the ocean, deep water currents occur deep inside the ocean beyond 300 meters as they occur far below the surface. They are not influenced by the wind. However, they arise as a result of variation in density of the ocean water and are controlled by the temperature and salt content of the water. Number 3. Vertical currents. Upwelling currents. Upwelling currents are currents that move from deep in the ocean, heading towards the surface. They are the one responsible for bringing organic matter from below the ocean towards its surface. For instance, they sweep nutrients upwards, helping some marine life. It can be seen when there are tremors or earthquakes on the surface below the ocean and the waves are pushed upwards. In Antarctica, upwelling currents pump nitrogen and phosphates off from the deep sea to bloom of algae and other plants. Number 4 is the downwelling currents. These currents move material from the ocean's surface towards its floor surface. Water can be forced downwards by the pressure of the wet water when currents converge or wind drives the ocean against a coastline. It is important as the dissolved oxygen in the sediments and water below would quickly be used up by the decay of organic matter. Additionally, anaerobic bacteria would take control of decomposition, contributing to a build-up of hydrogen sulfide, and only a handful of benthic animals would survive such toxic condition. Location of the different ocean currents. What are the names of the major ocean currents in the world? But we can still divide them into major ocean currents that circulate water in our 5 oceans. So, there's a generation of gradient currents. In, in oceanography, a current determined by the condition that the horizontal pressure gradient due to the hydrostatic distribution of mass balances the Coriolis force due to the Earth's rotation. The gradient current corresponds to the geostrophic wind in meteorology. In practice, the distribution of density is determined by measurements of salinity and temperature at a sea surface, of depths in a number of positions. From this, the geopotential topography of any isobaric surface relative to any other isobaric surface may be computed, and the horizontal pressure gradient may be expressed by the geopotential slope of this isobaric surface. In this way, relative isobaric surface currents are obtained corresponding to thermal wind in meteorology. If one's isobaric surface is known to be level, the absolute geopotential topography of any other surface may be computed by reference to this, and hence absolutely gradient currents are obtained where no isobaric surface is known to be level. The total gradient currents will consist of the relative gradient currents due to the distribution of density and the slope currents due to that portion of the inclination of the isobaric surfaces that is not the result of the distribution of density. See also geostrophic current. Different ocean currents approximate location and direction in a chart. So major cold and warm global ocean. So in the cold currents is the first place is the California current, Humboldt current, Labrador current, Canaries current, Benguela current, Falkland current, West Australian current, Okhotsk currents. In the warm currents, there's the land and North Pacific drift, North Equatorial current, Equatorial countercurrent, South Equatorial current, West wind drift, Gulf Stream, North Atlantic drift, North Equatorial current, Equatorial current, South Equatorial current, Brazil current, and that's all. And thank you, sir.